Hello everyone. We are discussing about the acid, bases and salt chapter. In the last video, we have discussed about the acid, their classification and some chemical properties of acid. Today, we are discussing about the bases. What is bases? Bases are those compounds which react with acid and form salt and water. Some examples: oxides of metals, all hydroxides of metals, and ammonium hydroxide. Oxides of metals like sodium oxide, calcium oxides, potassium oxide. Okay, and all hydroxides means sodium hydroxide, potassium hydroxides, calcium hydroxides, all so many hydroxides of metals are there. They are called as base. And ammonium hydroxides, among these ammonium hydroxide NH4OH, these are also called bases. So bases also called as a proton acceptor and proton acceptor or H plus ion acceptor from the acid. Okay, next, among the bases, some substances are there. They dissolve in water and form OH minus ion. So those bases are specifically called alkali. Means what is the definition of alkali then? Alkalis are those bases which dissolve in water and form OH minus ion. Dissolve in water and form OH minus ion in aqueous solution. Okay, next. Now the question is, all the alkalis are bases, but all bases are not alkalis, because some bases are there which are not dissolved in water. Okay, so just like copper hydroxide is completely insoluble in water. Okay, some other bases are there, just like sodium hydroxide fully dissolve in water and form OH minus ion. That's why sodium hydroxide is called alkali, but copper hydroxide, it is insoluble in aqueous solution. That's why copper hydroxide only, it is a base. Okay, I think you understood these things. Now the classification of the bases. There are several types of bases on the basis of acidity of the base, just like the basicity of acid, as we have already discussed in the last video. There are three types of acid: monobasic acid, dibasic acid and tribasic acid. Okay, it is actually depends on the formation of H plus ion. Similarly, in the opposite sense, there are actually the basis of acidity of the bases, the number of OH minus ion formation in one molecule of base, that is, this number is called acidity of the base. Here the bases are divided in two categories: for soluble base and insoluble base. For soluble base, those bases are soluble in water and form OH minus ion. So here the calculation of the number of OH minus ion which is produced by one molecule of base in aqueous solution, then this number is called acidity of the base. In case of insoluble bases, means some insoluble bases also there which are not soluble in water, but in this case the number of H plus ion in aqueous solution of the acid, okay, react with completely with one molecule of base. Okay, means here the number of H plus ion which is produced by the acid in aqueous solution, this number of H plus ion react with the completely with one molecule of base, then this number of H plus ion is called the acidity of the particular base. Okay, here the example for soluble bases, we know the soluble example of soluble base is actually NaOH, KOH. These are actually soluble base. Barium hydroxide also, and here insoluble bases: copper hydroxide, ferric hydroxides. These are insoluble base. Okay, now there are three types of bases on the category of acidity.
monoacidic base. Those bases in aqueous solution form one OH ion, okay, per molecule of the base. Okay, in aqueous solution, if it is it completely dissociate and form one OH minus ion in one molecule of base. Suppose sodium hydroxide in water H2O. Okay, so it completely dissociate in water and sodium hydroxide actually form Na plus OH minus ion. So here this is the 1 mole of, here in the previous it is not written, means it is 1 actually. So 1 molecule of sodium hydroxide, it produce 1 Na plus and 1 OH minus ion. So this number actually 1 OH minus ion, this is called acidity of NaOH. So we can say here the acidity of NaOH is 1. Okay, so for all monoacidic base, the acidity is 1. We can write here for monoacidic base, acidity is 1. Similarly, for potassium hydroxide also K plus OH minus ion is formed. So here the number of ion or OH minus ion is 1 only. So the acidity of potassium hydroxide also 1. Now for diacidic bases are those bases in aqueous solution, it form OH minus ion. Now here the number of OH minus ion formed in aqueous solution for one molecule of base is called diacidic base. Just like calcium hydroxide. Here, if the calcium hydroxide dissolved in water, it completely dissolved, almost completely dissolved, and form Ca2 plus and plus 2OH minus. Here you see the number 2 OH minus ion is formed. So hydroxyl ion is OH minus and 2 hydroxyl ions are formed when calcium hydroxide dissociate in water. So in this case, the number of OH minus ion is 2. So the acidity of calcium oxide is 2. Okay. So all the diacidic bases, the acidity is 2. Okay. But as we have discussed about the insoluble bases, so here we can consider as copper hydroxide. Copper hydroxide, it is not soluble in water, but it will accept 2 hydrogen ion when it forms salt. So copper oxide also has 2 acidity. Next, triacidic bases. Triacidic bases are those bases which in aqueous solution it forms 3 OH minus ion for one molecule of base. 3 OH minus ion in aqueous solution for one molecule of base. One molecule of base here. So here we can take the example of tribasic acid also. Just like aluminum hydroxide. Aluminum hydroxide, the symbol of aluminum hydroxide is AlOH whole 3. So here, if it is in water, then it will completely dissolve and it will form Al3 plus 3OH minus. The valency of aluminum is 3. Okay. So here 3 electrons will be eliminated from the outermost orbit. That's why it will be Al3 plus and 3 hydroxyl ion will be formed in aqueous solution. So the acidity of AlOH whole 3 is 3. Similarly, for triacidic base, okay, one insoluble acid also, insoluble base also there. We can write the example of insoluble base for triacidic base, which is ferric hydroxide. ferric hydroxide is completely insoluble. Okay, so in this case ferric hydroxide, when it react with acid, so it will accept 3H plus ion. Okay, so that's why its acidity is 3. Hope you understood this. Now the second category is on the basis of strength. On the basis of strength means when the bases are dissolved in water and it dissociate and form OH minus ion. Okay, so here there are two types of on the basis of strength. There are two types of base: strong base and weak base. Strong base are those bases which completely dissociate in water and form high concentration of OH minus ion. Means in the solution there will be high concentration of OH minus ion. So that time the solution is called strong base. The solution of the base is called actually strong base. Okay, just like sodium hydroxide, potassium hydroxide, these bases actually completely dissolve in water and dissociate and form OH minus ion, high concentration of OH minus ion. Okay, so next, weak base. Weak base are those bases, they partially dissolve in water or dissolve in small content and form very small concentration of OH minus ion. Okay, so these bases are called weak bases. Okay, weak bases, so many weak bases are there, just like ammonium hydroxides, copper hydroxides. These are the weak bases. Okay, the third category, that is on the basis of concentration. There are two types of base on the basis of concentration. It is concentrated base and another is dilute base. Concentrated base means having high percentage of base in aqueous solution. Okay, and dilute base means having low percentage of base in aqueous solution. So what is the, in the earlier we have discussed about the strength of bases, where in the category of the strength of bases we have to discuss about the measurement of OH ions, and here we have to discuss about the in the concentration we have to discuss about the amount of base in aqueous solution. Okay, this is the major difference between these two. In case of strength we have to measure the high concentration of OH minus ion, and in case of concentrated base we need to calculate the amount of percentage of base, okay, in aqueous solution. So this is the difference. So concentrated base means high percentage of base in aqueous solution, and dilute base means low percentage of base in aqueous solution. Okay, now preparation of bases. Preparation of bases, there are several methods for the preparation of bases. The first is direct combination of metals and oxygen. Direct combination of metals and oxygen. So now take one example. If one metal is combined with oxygen, on heating it will produce metal oxide. Okay, so take one example, calcium plus oxygen. So on heating it will form calcium oxide. Okay, another example you can take, magnesium Mg plus O2, it is also formed magnesium oxide MgO. Okay, next category is action with water with soluble metal oxide and with active metals. So we will see what will happen in case of soluble metal oxide when it reacts with water. Okay, some soluble metal oxide like sodium oxide react with water, then it will form sodium hydroxide, NaOH. Okay, Another, we can take calcium oxide, CaO. So it will be calcium hydroxide. You must check the balance. Okay, so these are actually soluble metal oxide, sodium oxide, calcium oxide, so many there's metal oxides. Now in case of active metals, if the active metals like sodium, calcium, potassium react with water, then what will happen? Just like calcium plus H2O, so it will form calcium hydroxide, CaOH whole 2 and H2. Hydrogen also produced in case of active metals. Okay. Next category is action with, it was action with water, now action with steam. Okay, means boiling water. So action with steam with metals, the less reactive metal, comparatively less reactive metals. So here you check some less reactive metals, means magnesium plus H2O. So as this is steam actually, so here it will be formed magnesium oxide plus H2, and another we can take iron Fe and H2O. On heating it will form ferric oxide plus H2. You must do the balance. Oxygen free, sorry, this balance will be Fe3O4 actually, ferric oxide. So here it will be 8 hydrogens are there, so it will be 4H2. Okay, so here it is steam. Iron is react with steam and form ferric oxide. Okay, when ammonia and water mixed with each other, means ammonia dissolved in water very quickly and form ammonium hydroxide. So see the expression here, when ammonia react with water very quickly and form ammonium hydroxide. So these are the category of producing base. Okay, next method of preparation of base is precipitation of metal hydroxides. Okay, all the hydroxides are insoluble in water except sodium hydroxide, potassium hydroxide and ammonium hydroxide. So these hydroxide actually can be precipitated out when some soluble salt react with sodium hydroxide and potassium hydroxide, and this hydroxide will be formed and it will be precipitated with one salt. So let's see here, salt solution like aluminum chloride CaLCl3 plus alkali means sodium hydroxide we are taking. So its salt is produced, normal salt, that is NaCl, but insoluble hydroxide which will be precipitated, it is aluminum hydroxide will be produced and it will be precipitated. Okay, so here this is the salt solution and this hydroxide, it is completely precipitate in the solution. Okay, next is by heating carbonates of metals in the activity series from calcium to copper. Okay, all the carbonates will be dissociate, will be decomposed actually in by given heat, and it will form metallic oxide and carbon dioxide. Carbon dioxide will be formed from metal carbonate. If it is decomposed in heat, then it will form carbon dioxide. Okay, this point you have to remember. Metal carbonates in on heating form metal oxide and then carbon dioxide. So take one example here. calcium carbonate CaCO3 on heating, it will be decomposed and form calcium oxide plus CO2. You can take copper carbonate also, on heating it will form cuprous oxide and then CO2. Okay, next category is similar. Here it is carbonate and here it is nitrates. So if nitrates is there, means NO3, so then it will be decomposed and form nitrogen dioxide and oxygen. Okay, nitrogen dioxide and oxygen, just like I am taking lead nitrate PbNO3 whole 2. If it is decomposed on heating, then it will form lead oxide, then NO2 plus O2. Check the balance. Check the balance here also. Here it is AlC3, so it will be 3. Here it is 3. And check the balance here. How many oxygens are there? 6. So here it is not 6. Nitrogen is 2. Now it's 4, 2, PbO. NO2. Okay, so 8, 10, 12. Here it is 4, 12. Okay, now it's okay. So when nitrates of metals on heating, it will be decomposed and form metallic oxide and then nitrogen dioxide and oxygen. Now action with carbon dioxide or air, when the alkali actually passes with through the air. Okay, so that time alkali absorb the carbon dioxide and form metal carbonates and water. Alkali absorb the carbon dioxide and form metal carbonates and water. So here suppose the NaOH forming here carbon dioxide, so sodium carbonate Na2CO3 plus H2O will be formed. You can take another example also, KOH plus CO2, so K2CO3 plus H2O. Now check the balance, it will be 2, carbon is 1, 4, so here oxygen also 4, 3, oxygen is 4 here, so K2. Now it's okay. Okay, so these are the general method of formation of bases. In the next class, we will discuss about the formation of acid rain and some uses of acid and bases, and then salt. Okay, bye everyone.